This question is from GATE 2016 Mechanical Engineering paper set 2, question number 50. The voltage length characteristic of a direct current arc in an arc welding process is V is equal to 100 plus 40L, where L is the length of the arc in millimeter and V is the arc voltage in volts. During a welding operation, the arc length varies between 1 millimeter and 2 millimeter, and the welding current is in the range 200 to 250 ampere. Assuming a linear power source, the short circuit current is dash ampere. Let's find out. It's given that voltage and length are related by this relationship. V is equal to 100 plus 40L. So we can find out the corresponding voltage for the length of wire. V1 will be equal to 100 plus 40 times L1 and V2 will be 100 plus 40 times L2. Let's substitute and find it. So 100 plus 40 into 1 millimeter, and here it is 100 plus 40 into 2. So in the first case it is 140 volt and in the second case it is 180 volt. Now current varies from 200 to 250 ampere. We need to decide what will be I1 and what will be I2 among the two. So as it is given that there is a linear source of power and length varies from 1 millimeter to 2 millimeter. So as the length varies, resistance will vary. So for 2 millimeter wire, the resistance will be more and therefore the current will be lesser. So as we have taken L2 as 2 millimeter, I2 will be 200 ampere, which is the lesser value, while I1 will be 250 ampere, which is the higher value. So now that we have V1, V2, I1, I2, we can use the relationship for short circuit current and open circuit voltage and find out the value of short circuit current with these values and then find out the short circuit current. So the relationship that we have is V by OCV, open circuit voltage, plus I by SSC, short circuit current, is equal to 1. Substituting for each of the cases, we will have 140 by OCV plus 250 by SSC is equal to 1. This is equation 1. And the second one, which is 180 by OCV plus 200 by SSC is equal to 1. This is equation 2. We have two unknowns, we have two equations. So we can find out these unknowns by solving them simultaneously. We can either eliminate SSC first and then find OCV and then substitute OCV to find SSC. But because we need to calculate only the short circuit current, we'll eliminate OCV so that we can get SSC directly. To eliminate OCV, we need to equate their coordinates. So here we have coordinate of 1 by OCV is 140 and here it is 180. Let's try to equate these two. So we'll multiply first equation with 180. Each and every term should be multiplied with 180 and multiply the second equation with 140. Same here. Let's write the result here. Before writing the result, we can say that we'll have to subtract in order to eliminate this term containing OCV. So after multiplying with the required factors, we are going to subtract the equation. So anyway, first two terms are going to get cancelled. No need to carry out the multiplication. It will directly give you 0. Now for the next two terms, we can write it as 250 into 180 by short circuit current minus 140 into 200 by short circuit current is equal to 180 minus 140. So if we take 1 by SSC common and take it to the other side, we will have SSC will be equal to 180 minus 140 is 40. It goes into the denominator on this side. So we have 250 into 180 minus 140 into 200 by 40. Carrying out this calculation, we get SSC is equal to 17,000 by 40, which gives us the answer for short circuit current as 425 ampere. Let's go back and fill in the answer. So the answer here, the short circuit current is 450 ampere. To learn more about this topic, you can refer to the NPTEL video, Lecture 7 and 8, Welding Power Sources Characteristics. It's from the course Fundamental of Welding Science and Technology. The course is by Dr. Pankaj Biswas. He is from Department of Mechanical Engineering of IIT Guwahati. I hope this solution will help you clear your doubt. Thank you.